I think we have got 1, 2, 3, 4, 5.
Yes, we have 5.
So 5 schools have come. These are individual students or it's a school? You can unmute and speak here. Please turn on the cameras. Hello, schools.
Hi, I'm also from school. I'm Raj Shekhar.
Yeah, can you please turn on the cameras? Hello. So there's a school, Vinith. Observer. Avesh Khan, please turn on the camera.
Hello, sir. Good afternoon.
Hello.
Good afternoon, sir.
Good afternoon, sir. All the users, please turn on the camera. Yeah. Thank you. So these are individual people or it's a school?
No, the thing is, school students have joined via WhatsApp link, sir.
Achha,
Via
through
YouTube
YouTube
link.
link. Okay.
Yes, sir.
Okay, okay. Got it. Okay. So Rashika, so you're also from the school or?
Yeah, I'm also from school. School technical GNLA. Yeah. Our students are joining from the library. I'm from the office.
Okay. 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 No issue. So let's start the session. Let me share the screen. Good afternoon, all. So today we have joined here for the session Arduino from curiosity to innovation. So build, learn, and innovate. So this is a very basic and entry-level session to teach a student who are very much new to Arduino and who wants to do something tinkering or do something more robotics or do some projects for the science fair or any other activities in their schools. So let me introduce myself. I am Rajesh Kushalkar. I am heading the open source hardware program under the FOSSEE project. The FOSSEE project is funded by the Ministry of Education, Government of India. So let's start the session. Arduino from curiosity to innovation. So who likes to open a gadget? Everybody likes to open a gadget. The curious child, whether it's a girl or a boy. So very first thing, when you give him a pen, he starts to open how to refill the thing, how to change the nib or anything like that. Everything is dismantled, he assemble it back. So this is how the very first curious mind works. Okay. Now, as the child grows, he gets a battery operated toy or something like that also. So there also you can say first he will start with how to put a battery. He understands that time what is positive and negative, how you have to place the batteries. Okay. So he learns from that particular thing because all this curious mind, there are a lot of questions and each question has to be answered. Okay. So now after playing with the toy, he knows how the thing works. Battery, he has played with the toy. Now second, he tries to open the toy. After tries open, he try to figure it out. Yeah, this is a motor. It is connected to some gear. Because that terminology, I'm talking about all the terminology what the child is trying to learn. The motor, then the gears, what is this part, what is that part. All these things are new to him. Why there are small gears, there are something which are big gear, how it is operating and all this. He may not be knowing all the mechanical parts and all this thing, but he tries to learn how the things work. Now this is moving this way, the motor is driving so and so thing, gear. So my car is moving in a speed way. So after that also, there's some curiosity in the child. How does a motor move? The moment I connect, what happened inside a motor that it moves? So further he goes, try to open the motor also. Then he sees there's some coil inside, there's some magnet also placed and all this stuff. So never ever stop a curious mind. Let them learn the things. Okay. After breaking only, they will assemble themselves only and they will try to learn the things. So this is how it starts breaking, then building. The building starts by building robots, building drones, and invent new technology. Okay. So as a child, you should always promote. I'm sure not breaking the things, but yeah, they will learn the things themselves in a very good way. So everything starts with a curiosity. So as I've told, the curious child opens a car. He wonders what's how the motor moves and all those things. Now, second part is the remote control. So everybody knows, yeah, if I press on off, the TV turns on. If I press the volume up button, down button, the volume of the television goes up or down. Change the channels and all this. But if you see, there are so many buttons on the remote control. Okay, so you see there are so many buttons on the remote control, which is pressed, which is not. So how the system knows? Why? Because this remote control has got a built-in system which transmits some rays wirelessly. It is IR. They will find it out what exactly it is, right? So you say this is called as IR. So remote works on the infrared technology. Now what does the IR is? So let them learn. So each key pressed gives you a different signal, and that different signal is decoded by the your television, and it knows, yeah, this is my signal is to turn up the volume, change the channel, mute the system. Okay, so like that it talks about the system. So there the thing comes that something is electronic present, so it is coded to recognize the particular code, and so then robotics or innovations, so this thing happens. So these are the few steps which leads to a child where he learns basics of electronics, coding to it, then further robotics and any other part. Robotics is just a small part of it, but we are just defining this thing, and then the new thing has been innovated. So what is Arduino? So Arduino is a small device. Okay, it's a programmable electronic brain. So there's small chip which takes all the instruction. We program this small chip. Okay, there are a lot of pins that you can see out here. Okay, and these are the pins where you connect your sensors. Now, what do you mean by sensors? Okay, so sensors are something that sense the environment. Generally, we call it as a physical computing. Okay, what do you mean by physical computing? Whatever the physical environments are there, how to sense that thing. The very basic example, I'll not talk about the physical computing or in the terms of Arduino or anything like that. Just a very simple example is turning on your light or a fan. The switch is turned on, the light turns on. If it is off, the light turns off. So what you can see, there's something is happening, the output is there. Something is input, the same way the output is there. Okay, so what in the Arduino we have got different pins. We call it as a digital pin and something called as an analog pin. Now what are the digital pins? As the digital says, either it is on or off. So what is your fan says? Either the switch is on or it is off. Okay, there is no other third state in it. Either it is on or off. So this is what is digital. Okay, Either now, if we just go for the analog part, okay. Now, same consider you take as a fan. The moment you turn on the your knob, the fan from 0 it goes to the speed changes to fast. Okay, this is gradually it is changing. So that is called as analog. Digital is what? Either low state or high. Either it is off or on. But what you take for analog? From slow, it increases to fast speed. Okay, so this is called as the analog part. So we have got different pins for the digital and analog in this thing. So this is a very small prototyping board where various sensors can be connected, various switches or output devices can be connected to it, and we can have various output, or we can create a lot of things in it. For example, this we call it as human made sensors. Now what is the our sensors, what we have in our body? We have our hand, wherever we touch, it's a touch sensor, what we call it as. We have got eyes, okay, we have got ears, we got mouth, we got smell, okay. So if you just try to compare that sensors with today's mobile devices, your cameras are your eyes, okay, your touch screen is there, earphone is the speaker, which is mouth is your speaker, then microphone is your thing which is listening to it, okay. Then all these sensors are there which gives an output for it. For example, if I have a hot water glass is placed in on the table, and I'm going to take the hot water glass. The moment I touch the glass, my hand senses something. It says that thing to your brain. Then brain reflects back, it is a hot, remove your hand from there. Okay. So what is happened? This is, we call it as a reflex. Immediately we reflex. But why it is reflected? Because through your brain it has been reflected. So what is the input? You are touching the glass is the input. It gets to your brain. The brain says to take it out. So Arduino, that's why we call it as we program that electronic brain. We program this small device out here to do certain tasks. Okay, like reading a sensors, like a temperature reading. I'm talking for control of the motor, the fan motor. I have given the example. Blink of LED light. So all these examples we will talk. But if there are a lot of sensors coming together in a one small devices, then we make it a robot or many other devices that we see. Now Arduino is like a brain, as I told you. There's some sense Arduino react to that and action. Now, for example, there's a temperature sensor which is connected to the Arduino, and fan turns on. So what here we are talking about, suppose in a room, we have this setup done. There is a temperature sensor, and we have written a program for Arduino where we define that the moment the temperature sensor senses temperature above 25 degrees Celsius, the fan should turn on. Okay. Now, what is a physical computing thing comes in physical value? The temperature is a physical value which is coming. And what is the reaction that Arduino takes? The moment the temperature goes beyond 25 degrees Celsius, the fan should be turned on. So this is already defined in the program that we are writing. So there is something input at certain things, it has to turn on. Now suppose we have written the program 25 degree, the fan should off on. If the temperature goes below 23 degrees Celsius, the fan should turn off. Now in this kind of situation, we already defined what is the input, what is the output, and how the output has to react. The input temperature, the physical temperature, it checks it continuously. The moment it goes 25 degrees Celsius, your brain or Arduino program, whatever is there, it tells to turn on the fan. The fan is running at its full speed and all this thing. Again, the room temperature goes down. Now, if the room temperature goes down again below 23 degrees Celsius, because this is a temperature sensor which is continuously sensing the temperature. Now it has gone below 23 degrees Celsius. Now again trigger comes in to turn off the fan. Okay, so what is something is getting input and something at the output, the things react accordingly. So real life examples for this thing is we have got Arduino can build smart irrigation, robots, home automation, weather stations, okay, air quality monitoring, drone, and all this stuff. So we'll go step by step. What do we call as a smart irrigation? I'll open this session to everybody. If you can just speak, what is exactly the smart irrigation is about? Please unmute and we can have the session. So what is smart irrigation? Anyone can please unmute and we can discuss. I would like to make some interactive session today. Okay, so smart irrigation. So nobody is answering, so I'll just start off. I'll give a very small, very simple example for this one. So at your home, you have got a lot of pots having plants in it. So what do? Every day in the morning, you fill up a glass of water. In each pot, you put one glass everywhere. Okay. So what happens? Plants get water, no doubt. But maximum thing, it just waits away. All the water which has been put it in the pot, it just wash away. Okay. So through the holes at the bottom, it just drip off. So there's a wastage of water. Okay. And unnecessarily we are over watering the plants. So there are certain sensors which are available which measures the soil moisturizer, how much moisture is available in your soil. So it tests that. So what happened if I have the soil sensor for the plant and this soil sensor is connected to the Arduino and Arduino tells if the level of soil moisturizer goes below this level. Now what is going to trigger? Now it is going to trigger a small pump which is going to water all the plants. Okay, got it? So this is automated. And if the soil sensor says, yeah, now my things are properly, moisture level is come, now stop the motor. So again, you say the input is coming that the plants are saying, I'm feeling thirsty, please water me. I filled it. Now I am not feeling thirsty. Please turn off the water. Okay. So a very simple example. What is that you are trying to solve is planting the water on your pots automatically. Same thing if you go for a large scale for farmers and all this thing. How it is done? The same thing is used with the temperature generally for the crops and all this thing. If you're having a very controlled environment where temperature, humidity, everything is checked and which crop grows is required, whether water is given to it regularly or not. So it has that soil moisture levels and all the things. Because what happened in if we overwater the field also, what happens? Whatever your nutrients are there in the soil, everything goes below the bed. The roots are not getting that kind of required material to grow. Okay, nutrition to grow. So limited supply of water and all this thing. Here the second thing what we are going to observe is we are not over wastage of water is also saved and all this thing in this part. Same thing for the robots. Home automation. Again, we are talking for the home automation right now. Is we are at the home, we just say if you have a home automation, turn on the lights, the automatically turn on, or there is a mobile application, turn on, off, or whatever is there. We try to do it with our application only with a mobile which is connected. Okay. So, and we are just trying to control the things. But just imagine this kind of small device. If this kind of small device is connected to internet, okay, means say this small device is now talking to the internet, and through some application I am able to view all that thing. So what we call it this as Internet of Things, IoT. Okay. The moment this small devices gets connected to the internet, we call it as Internet of Things. Like my home, suppose my home is connected with these small devices where all the my fan, my AC, all these things are connected to the internet, means through device is controlled by these small devices, and this is connected to internet. So I called my home as internet ready. Okay. So what happened now here also, I have got a certain thing. So I'm moving from my office. I'll be reaching the home. I set it I told my system the moment I reach home, my room temperature should be pleasant at around 24 degrees Celsius. Okay. So the moment I say that part, the home automation system is not going to turn on the AC directly and keep it at 24. What he is trying to do, he is going to see my how much time I'm going to take. So it is watching my space through GPS. Yeah, it is going to take half an hour to reach home, and it is going to take only 10 minutes to turn on the AC and to come at that particular temperature. My system is intelligent that much. So the moment it tracks me, and if I'm 10-15 minutes away from my home, it will automatically turn on the AC. The moment I enter the home, I have got a pleasant temperature, whatever I required. Okay. Same thing, weather station, air quality monitoring, and all this thing. Today's weather station is there. So where we try to calculate on the same temperature and humidity is there. Okay. Then we have got air quality. Now, air quality, there are certain sensors which are available which measures small particles. That small particles which goes through your nose, it goes through your lungs, and it goes through your blood vessels also. These are called as PM 2.5 particles, PM 1 particles, and all the things, which are very small particles which flows in your bloodstreams also. So to stop all that thing, there are a lot of sensors which are available, which can operate, and it tells you about what is the quality, air quality of your place. Now, why Arduino? Why we so popular? This is such a small device. It doesn't cost much. Okay, so we can use this small device to prototype your first program. Okay, first step that you have to do. So try to, and it is very easy to learn. It's an open source tool. Lot of materials are available. Okay, and it is used worldwide, and it is the best tool for learning a school-going kid or a college-going student also to learn electronics and programming. Okay, so generally for all the programmings we taught, very first thing for Python programming or C programming, the very first thing what we call it as a hello world is your first step of your program. But in electronics, the first step of your program is blink of an LED. Okay. So why learn Arduino? It teaches you coding, it teaches you electronics, it teaches you design thinking, problem solving, innovation. Now, why we call it as a design thinking and problem solving? We are not creating anything just for the fun or anything. What exactly problem you are defining, what you are trying to solve it. Okay. Now, for example, you see there's a garbage bin at one of the place where it is full and nobody comes and picks it up. The garbage is always there, it is lying there only. But if you have this garbage bin which sense that the garbage is the bin is full, it indicates your corporation, municipal corporation, and tells them so and so area the garbage is full, please come and collect it. So it comes under that smart cities and all these things, so it will come and collect it. So that's our problem, that garbage, nobody, but these small devices and all this thing, whatever we are talking about, It will send something that the garbage is full, please send it. Second problem, for your school or anything, I'll just say, if I want to automate my school attendance system, okay, so now many people they use thumbprint for the school attendance and all this thing. For the many of the teachers or anything, they must be having thumb impression. Whether the same thing, if you can put it at the school classroom levels also, how many students are attending this thing. So these are very common things nowadays which are available, and in our IIT also and many of the colleges, this kind of things are used for attendance systems basically. Okay, so very first thing you have to see what is the problem, then you have to go and try to design it, and then you have to work on it. We promote not to write a single line of code before what is the you are addressing the problem and design the things on the paper. After that thing, you have to first do it in a simulation mode only. Once you are done with the simulation mode, write the program in the simulation mode and see the output. And once you have seen the output and everything is shown properly, then you can go for actual hardware and try to build with the circuit. The very first thing, always try to do with the simulation. So we'll demonstrate you two simulation tools that can be used for your labs. So feature technologies, Arduino is used in robotics, IoT, electronics, AI hardware. So AI also something which is learning, the hardware which is learning. Okay, so many of the people talk about now the sign language and all these things, how we can, the cameras, because nowadays lot of this kind of small devices are equipped with the sensors, but it has equipped with cameras also. So camera can be detect and how the things goes further. So decision making can be done from the hardware side itself. Now AI with the hardware is what is called, we call it as I got a data for last 10 years. What is the temperature and humidity of this particular area? Now, if I have a small weather station, I can have the decision making that today the weather is pleasant, today it will be rainy, today it will be cloudy. So this kind of prediction I can make locally also with the data which is available for last 10, 20 years. Okay, because these are the things which are required. The data is required for doing the machine learning. So careers is robotics, again, IoT, space technology, smart cities I have talked about, agricultural technology. In today's world, Arduino or the small devices are widely used in space technology, smart cities. To see everywhere, you can see the cameras are there. It is checking the traffic conditions. It is checking even the noise levels and all these things. So it detects the noise level. Based on that noise level, it can try to direct the traffics also. Okay, agricultural, medical devices. So medical devices, you can see how much your pulse is coming. Now you have blood pressure is monitored, heart pulse is done. So there are a lot of things that can be used, sensors which are available, which are used for the medicals also. Now again, coming back, input and output. Okay, I have already explained. We call it as IO. I stands for input and O stands for output. So input is something which is the information given as an input. Like the input, turn on a fan, so we switch on the switch. So that's the input. So what's the output for that? The fan is rotating is the output. So there are a lot of things like examples like buttons, sensors, microphone, temperature sensors, motion sensor, physical movements or anything like that. These are the input to your Arduino. And what's the output? Depends on the input. It will turn on the motor. The LED will start blinking. It will display, will show you something output. Now, depends on the temperature sensor, display is coming 25 degrees Celsius, 23.6 degrees Celsius. So it is showing you that output. Okay, buzzer. It will buzz out movements and all these things. These are outputs basically. Again, simple example as I mentioned, turning on button. The moment you press the button, The Arduino sense the button is pressed, it will turn on the LED. Okay. Same thing is there soil moisturizer. Motion the soil moisturizer is detecting a moisture is less in this particular thing, so it will turn on the pump. Okay. Before going on the demonstration and all this thing, I would like to show a very small video that has been, it will be clear for you.
Tanish was not an ordinary schoolboy. He was curious about how things worked.
Why does the fan spin so fast?
Good question, Tanish. Let's find out together.
At home, his curiosity turned into action. Every broken gadget was a new mystery waiting to be solved. One day, Tanish discovered something amazing: Arduino.
So code can control real things.
With patience and practice, Tanish built his very first robot.
It works! Wow! Where did you buy this robot? I didn't buy it. I made it.
That one sentence changed everything.
Can you teach me? This is called the Blink program. Every journey starts here. Press the button. I did it! The LED turned on.
Step by step, curiosity turned into confidence.
Wow! We're controlling it wirelessly.
Together, they built more than projects, they built skills.
Next, drones! Yeah, drones!
Years passed, but curiosity never faded.
Remember our first blinking LED?
And now, drones for the nation.
The Curious Minds, one open source tool, a stronger nation.
This robot helps us learn about science.
I just hope it has sparked some curiosity in your mind. Okay. So I'll just tell my colleague Pratik. Okay, we'll have the demonstration session now. We'll demonstrate a few of our product that we have developed. So you can use this simulator for your experiments here.
Hello, good afternoon, everyone. So, we will show you one more video where we have created multiple experiments. So this is the video where what we have done is we have created a memory game that the Arduino will give the random LED. It will just generate a blink, and we have to remember which LED it has blinked, and then we have to connect the associated push button for it. If we fail to do that, the the controller actually restarts and starts from again. The idea behind this is we want the students to memorize the game, that it helps you to memorize certain number of patterns, and so that whenever it comes from the first LED, second LED, third LED, and it goes on till the fifth and sixth LED, so the pattern continues. And we as a user, we have to remember what LED has been blinked by the Arduino, which is a random sequence. So that is the idea behind this. Then we have a wireless robot. We control it using the ESP module. It is a part of the family of Arduino, and we have created this website where we have designed forward, backward, left, right, and stop button, and then we have multiple eyes, which is associated with different faces. Then we have a digital clock. So where you must have seen in movies that they use a sand in a bottle to count the number of hours or minutes which has been passed. So here we are using two 8x8 LED matrix. So in a minute, all the dots uh, go from one side to the another. So since I have just altered the position, you can see one by one, with which each passing second, each dot is being passed from one matrix to another matrix. So it serves as a digital sand clock. Then we have automated movement. So we have used servo motor and potentiometer. Potentiometer is used to control the orientation of the servo motor, and you must have seen in all the machines which work on their own. So we have to give some information for them, that you have to pick the object from one place and rotate yourself back to another place, and then dump this object into the black box. So right now what we are doing is we are training the controller to memorize all the steps from step 1 to step 2. And now you can see the servo motor has dropped the white block in the black box. So we save this information, we feed it to the controller, and now we don't have to do anything. The controller automatically takes the white block, goes to the other position, and then drops it to another black box. It goes on repeatedly. You don't have to worry about always worry about the controller, whether it's right or not. Then we have a RGB game. The LEDs from the RGB strip are come from the red, blue, and green LED comes, and we have three buttons, namely red, green, and blue. So we can control. We can actually give emit the LEDs and kill the LEDs which are coming from the opposite side. So you can see on the screen we are killing all the LEDs, but as soon as you go on and on, the level adds up, and if you miss to kill all the LEDs in the given specific time, the game ends and it goes on to the starting mode again. So we will go to Electro blocks. I will just share my screen with the website. So yeah, so this is the Electroblocks website. I'm sharing the link in the chat box as well. So those who are using the laptop, they can actually use the link to go and perform their own experiments, which I'm teaching right now. So on the right hand side, you can see there is a simulation window where a breadboard and Arduino is connected. This red wire represents the positive 5 volt, and the black wire constitute for negative line, the ground line. And here we have a simulation button. On the left side, we have different types of blocks that are used. So Electroblocks, we propose students to use the Electroblocks platform when they are new to Arduino, so they don't have to worry about the connection, the hardware connection of components. They don't have to worry about writing the code. All they have to make sure that whatever experiment they have in their mind, the logic should be right. So suppose we will demonstrate a experiment of blink of LED. So what is the idea behind blink of LED? We want an LED which is turning on, staying on for a certain amount of time, then turning off, and then sets off for a certain amount of time. So this process should be continuous, and for that we need the logic that the LED should be first block. So in here in the add-on section, we have the LED block. So we will just click on it and drag this block outside. So for now, I will just place it outside here. So you can see it has turned to gray. So we have to make sure that all the whatever blocks you are using for the loop block, it should go inside the loop block. So you can see since it is outside, it has turned to gray. But as soon as I am putting it inside the loop block, you can see it is right here, and in the simulation window itself, you can see an LED which is connected to pin number 2 has been appeared. So we can change the color of the LED as well. So you can click on the color palette and you can change it to let's say color green, and a green color will appear on the screen for the LED. You can also change the pin number which is connected to Arduino. So let's say I want to change it to pin number 5. So again, it will change the color, change the pin number to 5. So now this is your first block. So this is your turning on the LED block. So let's say I want a delay after that. I want to make sure that this LED turns on for a certain amount of time. So I will click on the delay in the time block. I will bring the wait for a few seconds block, and I'll edit I can change the number of seconds that I want to keep the state on. So I can change it to, let's say 1 second. So this is, so till now we have covered 2 blocks. We are turning on the LED, and we are making sure that it stays on for 1 second. We want, so the blinking part is where the LED also turns off. So we also want the LED to be turned off. So we will add another LED block just below the wait block. Make sure the pin number are same for both the LEDs, and you can see the LED, another block has been added for the LED, and you have to make this block as off to make sure the sequence goes in the correct manner. And again, go to the time block, bring out the wait block outside, place it below the LED off block, and change the time to 1 second. So what this does is it sets a scenario where block by block it will just turn the LED on first, then it will wait for 1 second to make sure that the LED is on for 1 second. After that, the LED is turned off and it will remain off for 1 second. So here we have the option of playing the LED, playing the simulation. So let's start the simulation. You can see this LED which is turned to pin number 5. It is turning on and off after every second. So you can see the simulation over here. Just below this, so suppose if you want to check at each step what is happening, so just below it we have a option for next step. You can you can click on the next step, and you will see it is highlighted what is the state of the line of code which is doing right now. It is highlighted. So on the left side as well, the block is highlighted in the blue in the yellow color. So what is the state of this experiment? So if I again click on the next step, it will say step 3, turning off the LED, and same block has been highlighted here on the left side. So similarly, so this takes care of connecting the hardware. So you don't have to worry about the hardware. But as I also mentioned that you don't have to worry about the code. So in the code section, this is the code section. The Electroblocks generates a code for you for the blocks that you have arranged in a particular manner. So let's build another circuit another time. So I will just dismantle these blocks and place the blocks one by one. So you can see this is the Arduino syntax. So void setup is where you mention the component that you are using, mention the component that have been connected to which particular Arduino pin. So since we are connecting Arduino, the LED to Arduino pin number 5, you can see the changes appear in the void setup. So you can see pin mode 5 output. So 5 is the pin where LED has been connected, and output because an LED is an output component which gives the reading out. In the void loop, you will see all the code which is supposed to be running continuously in a loop. So you can see digital write pin 5 is high. So whatever component, in this case LED, which is connected to pin number 5 has been turned to high. So we will add a wait block just below this, and you can see a delay of 1000 milliseconds have been added in the line of code. So 1000 because Arduino takes a second as a 1 second as 1000 milliseconds, and we don't write 1 second. It takes the reading in the milliseconds itself. So that is the reason 1000 is appearing. But in actual 1000 millisecond is considered as 1 second in Arduino. So we will take another block and place it just below this. You will see right after that, first we turned on the LED, then we gave a delay for it, then we are adding a block where LED is being turned off, and then again we will add this block for the wait, and a delay of 1000 seconds has been added. So you don't have to worry about the writing the code. The Electroblocks on the back end generates a code for you. So let's say you have all the you gained all the expertise, and you want to, so all the simulations are done and you want to upload the code. If you have the hardware with you, and then you want a hardware where you have connected all the LEDs, all the components to the Arduino, and you want to check whether the whatever code that has been generated to you, whether it works or not. So I will show you a demo where I have the Arduino connected, and so yeah, so as you can see on my screen, so as you can see on my screen, there is an option to upload. We can click on it, and then we can see an option to upload the code. You just have to click on it, connect to the port which has been shown on your screen, click connect, and once the code has been uploaded to the Arduino, you will see a message that good job, coding has been uploaded. So you will see the LED turning on and turning off after every second. So that implicates that whatever code that being generated by Electroblocks is actually working, and we can upload the code directly to the hardware. So let's say I want to change the pattern of blinking LED. I will change the blink time for on LED as 3 seconds, and let us keep the off time as 1 second itself, and we can upload the new code. So the code has been uploaded now, and you can see the LED is LED is turning on for 3 seconds, and it is turning off for 1 second. So this pattern will run on forever until and unless we disconnect the pin or the LED from the Arduino. So how many of you are doing this session on their PC? So can we have an info on the students who are doing it? You can raise your hand, or you can just message us on the chat itself. Naresh Saula. Okay. So were you able to complete this LED blink experiment? You can unmute yourself.
Yes, sir.
Okay. Great. So did you find any difficulty in completing this task?
No, sir.
Okay. Great. So anyone else who is doing the task on their system, or any student who is having difficulty understanding this point, that how we are dragging the blocks, and any query, we will be able to answer it. You can ask any query. Okay. If not, then we will move to the next experiment. So I will just wait a second. Yeah, someone is saying.
Yes, sir.
Yes, Ima.
Sir, what is the name of the site? Can you please tell?
Electroblocks. I have shared the link in the chat box. It is pronounced as Electroblocks.
Thank you, sir.
Yeah. Okay.
Pranav, what if there is there is no specific sensor available in this? Can we add?
There are. So as you can see, so these are the add-ons where the simple components are there, and just below it, the sensor tab, you can see analog, digital sensor, motion sensor, RFID, temperature, and thermistor sensor. So we have a number of sensors which are available with us for this platform.
Okay, you keep updating that, is it? I mean, if there is a new sensor in the market, you get it updated.
Yes, definitely. Yeah, for now we have these many sensors. So analog sensor cover mostly 4 sensors, if I'm not wrong. So I'll just give a demo that let's say we bring the setup block, and we have types of potentiometer, photo sensor, soil sensor, and a normal sensor which we can create on our own. So these are the analog sensors that are available for digital as well. So see, if I bring out the setup block for digital, we have touch sensor, IR sensor. So like that, we have sensors, but we will definitely keep on adding as we can.
So one of the students asked for IR blaster.
Sorry, sir.
One of the students asked for IR blaster.
IR.
Yeah, infrared blaster.
Okay. IR, I'll have to check if we have the IR sensor.
What about the transmitter and receiver? Yeah, I think they are part of that IR remote. I think so, but it seems it blasts multiple, maybe in multiple different angles probably. So,
actually, sorry, sir. We like can you like speak up, because the voice is actually a bit low.
Oh, is it? Am I okay now?
Yeah. Right. Yes.
Right. So one of the students asked for IR blaster.
IR blaster.
Yes.
Okay, blaster B. Okay. So no, actually we don't have that sensor right now updated on the website.
Okay.
But we are in the process of adding as many of the sensors as we can, so that the students can get a hang of it. And this platform is basically, so what we do is we first make sure that students are able to create a logic behind their experiment, And once they're comfortable with that, then we move on to the another platform that I'll be coming in like 5 to 10 minutes. The another platform, which is Arduino on cloud. So on there they can have multiple sensors, multiple components, and then they will have the liberty of using their own experience of writing their code and writing like connecting the wires of the circuit.
Right.
So,
The reason why I had to ask that question was like,
yes.
Our school has adult tinkering lab,
Okay, that's great.
and the students have tried many of the sensors, and when they are not able to find a sensors in these kind of platforms,
Okay,
they're trying to check with us, like, if we can add our own sensor to it. If so, how would I add that?
understood. Yeah, right. Yeah, there are like few things that we have to make sure that whatever readings, whatever the parameters that we want for that sensor to work, which it should be taken to the electro blocks, and it should give the readings as well. It can't be the case where we are just creating a setup block, but it is giving the same reading of some other sensor. So that we have to make sure. But I think it is possible. We will take it as a feedback, and we will work on it.
Thank you.
Yes. So coming back to the platform, so I will give another example where suppose you are entering your room, and so this is the light example. This is a basic example. But suppose, what if you want to control this LED? So just an example of a light. When you enter the room, the light doesn't turn on automatically, right? You have to turn the switch on. So it is basically controlling the light using a button. So similarly, we will have an experiment here now. So for the button setup, in the sensor section, we have a button column that for first we need to set up the button. We have to bring out the button setup block outside, and I will just go back to the home screen, and you can see a button appears on the screen which is connected to the breadboard and to the Arduino pin number 2. Similarly, you can change the pins here, make it pin number 7. So that works. And now comes the logic part. So previously for the LED blink, we made sure that the LED is turning on first, it is staying on, then it is turning off. But for this particular experiment, controlling the LED with a push button, we have a condition where a certain condition is met, only then LED should be turned on. So that condition is only when the button is pressed, the LED should turn on. And for that condition, we have a logic block available. So it is a if then block. We will just drag it outside and place it inside the loop block. So first it will check whether the button is pressed or not. And for that, we will go back to the button section again, bring out this second block. It will say button 7 is pressed. It will have a question mark. It will check whether all the buttons have been pressed or not. If it is true, if that condition is true, then we can say you can turn on the LED, which has been connected to pin number 5. So you can see in the circuit diagram, a push button is there, a hand is there to press the push button, and an LED is there. When the condition is true, it will turn on. We will add a delay, and we will add another LED block to turn off the LED. So let's say I'm turning on the LED for 3 seconds. So the LED will turn on only when the button which is connected to pin number 7 has been pressed. But so suppose let's say we will run the simulation. I will just zoom in. We will just run the simulation. You can have a look here. The hand is there to press the push button, and when the condition is true, yeah, just a second. I made a wrong mistake. So this should be on. When the button is pressed, it should turn on. So I will just run it. So you can see the LED is turning on for 3 seconds, and then it is turning off for every loop. But what if the condition is not met? What if the LED, the push button is not pressed? For that, we will add another block just below if then block. So it will directly, it will check whether the LED is, the button is pressed or not. If it is pressed, it will run through this command. If it is not pressed, it will directly come here. And how we can control the button setup is in this button setup block. So I can uncheck this box. So what this will do is, it will, for the entire duration of the simulation, it will assume that the button is released, it is not pressed. So you can see earlier there was a hand on the push button, and now there is no hand, and a message as released appears on the screen. So as you can see, when I'm playing the simulation, the LED is off continuously. But if I check this box, the button is pressed, you can see the hand appears, you can see the pressed message appears on the screen, and when I play the push play button, you can see the LED is turning on for 3 seconds, and then it is turning off. So likewise, we have multiple projects, demo projects. So starting from blink of LED, traffic light, automatic parking gate, where servo motor has been used. Then we have a car parking system, RGB LEDs. So you can go ahead and create your own experiment, or you can just try these demo projects which are already available on the platform. Then you can have the expertise of learning, getting the knowledge, learning how the hardware works, learning how the circuit connection is made, learning how the code is been written by the Electroblocks platform, which is going to be helpful for you. And after that, once you are certain that okay, these are the things that I have learned and I can definitely go to the next level, then you can come to the Arduino on cloud. I will share that link with you. So this is the Arduino platform. Yeah, I think my screen is visible. So till now, for the Electroblocks part, if anyone have a doubt regarding anything like the code generation, the circuit generation, if anyone have a doubt, they can ask me before we move to the Arduino on Cloud website. I think there were 2 students who were doing the simulation on their system. So if you have any doubts, if you are facing any issues, you can ask us, or any student for that matter who are attending the session from the school. If you have any doubts, then yeah, I think Pratik you have some doubt. You can come near to the system and you can, so that we can hear you clearly.
So how we can keep the LED and breadboard in the workspace, sir?
Can you, Pratik, can you come near to the system and speak up, because we are not able to hear your voice clearly.
Sir, my voice is audible to you?
No, Pratik, we are not able to hear you. The voice is not clear actually. Your voice is coming, but it is breaking a lot. You can use the text message as well. Whatever doubt you have, you can write it in the text, so that we will be able to answer you. We will wait for a minute so that you can answer your question. You can ask your question, and then we will answer you. How can we keep the LED and other things in the workspace? Okay. How can we keep the LED and other things in the workspace? So I think what you mean to ask is, so this is the LED. So this is the simulation area, and this is the canvas where we are dragging all the components. And I'm still not clear about regarding your question, like the way you have asked. How can we keep the LED and other things in the workspace? So are you saying you want to save it, save your experiments? If that is the case, then so suppose I want to save this experiment. We have an option to download the example. So either you can download the entire project, you can either download the C++ code that has been generated by Electroblocks. We prefer you to download the entire project so that you can have it access, you can have on the access of anywhere whenever you are using a different system. Yes, I hope I have answered your question. If not, you can again ask. Simulation space. So simulation space, so you can increase the size, you can make sure that you can zoom in, zoom out. If you are thinking that can we move this LED, no, because it is generated backend from the backend, so it will stay fixed. Whatever orientation that has been given by the Electroblocks website from the backend, it will stay the same. It won't change. So you can't actually move this component. So yeah, so it is rigid. Okay. Oh, I think someone else asked. Can you please share the link again? I can't find it in the agent. Okay, acha, haan. The link has been shared by my colleague. Okay. So for the so let us move on to the another simulation tool. So that is called as simulation.fossee.in. We call it Arduino on Cloud. So I will just share that link here to you again. Yes, Naresh Chawla.
Sir, where do we get the button block?
Where do we get the button what?
The button block.
Button block. Okay, fine. So in the sensor section, just you can click on the sensors, and there is a button block. So this button setup block is what we have used here. So it is used to set up the button. So where you want to connect the button, how many loops you want to make sure that the button is true, then whether the button is pressed or not. So these are the things that you set up in a button setup block. And for this block, again click on the button, and just below it we have a block asking whether the button is pressed. So this is where you will find whatever blocks which are available on the Electroblocks platform. Those are available here. All the blocks which are used for logical thinking, the calculations, the variables, color, those blocks will be here. The blocks for components will be under the add-ons. The blocks for the sensors will be under the sensor block. Naresh, does that answer your question?
Yes, sir. Thank you so much.
Okay, yeah. So I have shared the Arduino on Cloud link. I will share my screen as well. So this is the landing page of Arduino on Cloud. You can those who have the system, they can use this link, and you can go to the launch under the Arduino on Cloud, and we can see there are two tabs. One is Explore Experiment, one is Launch Editor. Before going to the actual editor, I will just walk you through the Explore Experiment tab. Yes, so this is where we have created a document for everyone. that we have around 10 to 12 experiments where we have given all the data of the experiment of the task that the student should be doing. Just like in your classroom, the journals are there. We have given aim, the components that are required for that particular experiment, what that component actually does and how it is used, how we should be using it. Then we have given a circuit diagram for that particular experiment. Uh, then we have given a code as well. So suppose you have written the code but you are not sure whether the code is right or wrong, you can always take a reference from here. We have also explained the code as well, so that we don't want you to just mug up the code and write it down. We want you to understand so that it helps you to write a major project where multiple sensors, multiple components are used, and the logic should be built from your end as well. So that is why we have given the explanation for the code. And then we have an output video where we have shown what is the expected output from this particular experiment should be. And once you are done with all this, we have given the assignment as well, so that it is a small change in your experiment, what you should be doing, whether in terms of connection, whether in terms of coding. We don't mention where you have to change the parameters. We just give you a problem statement on that particular experiment, and it is from your end. You have to make sure that you are finding the right answer, whether it is changing the code or whether it is changing the circuit connection. So coming back to the launch editor again. So we will go to the launch editor. So this is the basic UI. So this is where the code will be written. So this is the play simulation. On the left side, you will see there are different sections. In the general section, we have a resistor, breadboard. In the controllers, we have Arduino. In the output, we have buzzer LED, motor, 7-segment display, servo motor, RGB LED. In the input section, we have push button, ultrasonic sensor, PIR sensor, temperature sensor, photoresistor, a potentiometer. Did someone? Okay. Yes, Pratik, you have a question? Yes, for now it supports only Arduino Uno. Okay. So yeah, so as I was saying, so we will just create another, say a similar example to what we have done for the electro blocks. We will create a blink of LED experiment. So we in the document, if you see, I will just enlarge it. In the document, you can see in the blink of LED experiment that what are components are required. So we required an Arduino Uno board, we require a breadboard, an LED, and a resistor. So we need these 4 components to complete the Arduino experiment. So we will try to replicate the same. We can bring from the general section, we can bring the breadboard out. From the controller section, we will bring the Arduino Uno. From the output section, we will bring the LED. And again, from the general section, we will bring the resistor out. So these are the 4 components that we require for this experiment. So the breadboard part is I want to explain the breadboard. So you can see, even I'm hovering my cursor here on this point, the entire row is shown as in the single color. So that says that these lines are horizontally connected, internally connected, similar to this line, and these lines which are vertically connected. You can see all the 5 lines have been connected vertically, and they show that with the LED, the light strip. So what we do is we generally prefer to use the horizontal lines to connect the positive 5 volt, 9 volt, or 12 volts, and ground pins, and whatever components or sensors that you are going to use, we prefer to use it here, so that you can have, suppose if you connect the LED here, you will have all the 4 pins which are connected to the LED, and use it for some other purpose as well. So let us try to build the circuit. So can anyone tell me, any of the students, why the resistor is used generally? What is the role of the resistor in a circuit? Okay, you can raise your hand and you can answer them. Yes, Namrata, yes.
So the resistor resists the currents passed by the LED or any other component.
Right, exactly. So that is the reason we want a resistor connected to the LED. The reason behind that is Arduino emits 5 volt of voltage, and we don't want so LED does not require that much current, and we want the resistor to be used so that the LED does not break, so it does not get damaged. So for that purpose, we will show you what happens when we don't use a resistor in the LED circuit. So you can see LED has 2 legs, one is positive and one is negative. So what we will do is we will connect this negative leg to the breadboard. What you have to do is to connect it, a wire is required. You just have to connect on the negative leg, come down, and just connect it to any of the horizontal line. So let's say I'm connecting to the bottommost line, and then I have to make sure that ground pin from the Arduino is also connected to that particular line. So now I have connected this. So this negative leg of the LED has in turn has been connected to the ground line, because both the lines have been connected to the same single line. And now let's say I want to connect the LED to pin number 10. So I'm bringing the positive from the positive leg. I'm bringing the wire, and I'm connected to pin number 10 here. So this is the circuit without the resistor. So let us just write the code. So as mentioned in the electro blocks, LED, the void setup is where you write the component parameters, component features. So suppose LED is being connected to whatever pin, and so that has been mentioned in the LED void setup block. So we will write the code for it. Since the LED is termed as output, we will write output. And in the void loop, we will write the entire code that we want it to be running forever. So we will write the code for it. We will give a delay of 1 second. We will again write the LED line and make it low. And we will give a 1 second delay again. So this is the code. You will see in the shared document as well. So this is the code. So the only change is for the explanation reference, we have used 13, but in our system, we are using pin number 10. So I want to show what happens when you don't connect the resistor in an LED circuit. So we will just click on the start simulation button and see what happens. So you can see the LED has burst message appears on the screen, and there is no blinking of LED here. So in a way, why we want to promote the simulation platform is for this simple reason that we don't want you to directly go to the hardware components and have the option have the risk of hurting yourself or damaging any of the component. We want to make sure that you learn all the simulations here, make sure all the connections are right, and only then, once you are sure about it, only then go to the hardware part. So I will just delete this wire, and I will try to connect it via resistor. I will just connect one end of the resistor here, and the other end will go to pin number 10. So the code remains the same. We will just play the simulation again. And now you can see the LED is blinking now. So the current has been limited using this resistor. Another thing that you will see, a message appears on the bottom of your screen in green color. So what this indicates is the code that has been written by you, logically it is correct. It does not mean you have written the code and the output should work as it is. So an example for that is, let's say you have connected this LED to pin number 10, but in the code you write pin number 12. For all the lines you write pin number 12, and then you try to simulate this code. So this will tell you, it will again show you in a green color, but what it tells you that whatever code you have written, that is right. It is the hardware that you have to look at if your circuit is not working as you want. So that makes it difficult for students. So they will say, okay, the message appears in the green color, but my circuit is not working. Then you have to cross check it with your code and your hardware, whether all the connections are done properly, and the pins that have been connected to Arduino are mentioned properly in the code as well. So this is one part. Second part is where, so suppose a new student is trying to learn this code, how to write the code, but by mistake they forgot to write the semicolon at the end of the sentence. So this is where I have removed the semicolon, and I will just start the simulation here again. So you can see the Arduino cloud from the backend has given a message that there is an error, and the message has been highlighted in the red color. So expected semicolon before inversely curve brackets. So that is where you will see the error. What is the error has been also shown it to you. So you have to go back to the code again, make sure where the curly braces are, and just before that you have to write the semicolon, and then you can run the code again, and then you will see a message in the green color appears, and your LED is also blinking. So apart from that, we have an option of changing the wire of the changing the wires. So we will keep this wire as black, but suppose I want to change this wire color. I will just click on it. On the right side there is a pop-up window. I can change the color to red, and you will see a red color appears on the screen for that particular wire. Again, so for this experiment we have only two components, a resistor and an LED, but there will come a time where you will have multiple sensors or multiple wires in your circuit, and for now this is okay. But if you have multiple, like say 8 or 10 wires, you don't want this kind of orientation of your wire. So we also have an option of auto arranging the wires, so that allows, so when you click on it, the Arduino Cloud platform automatically aligns all the wires accordingly, and so see, you can see the wires are aesthetically right. It is aligned properly, so you don't have to worry about when there are multiple wires. You just connect from one point to another, and then use this option to auto arrange all the wires. So we have a code section, simulation section. You can undo, redo from here. You can download the entire project from here, export JSON file, you can save your project temporarily. It will stay on in your system until the caches are cleared. You have an option of zoom in, zoom out. We also have a gallery where multiple examples are given. So let's say I want to use I want to give you an experiment of LCD with breadboard. So okay, so before going to that, any of the students are doing the experiment using the Arduino cloud? Okay.
Yes, sir.
Okay, Naresh. Yes. So, have you faced any difficulty like writing the code or connecting the
No,
wires?
no.
Okay. Yes, Rajesh sir.
Sorry, it's a by mistake.
Okay. You can ask the question.
There's no question. By
Okay.
mistake, I did it.
Okay. No issues. Yeah. So so what we will do is we will see. So this is what I was talking about. So in this you have multiple wires with multiple colors. So when we generated this experiment, we also made sure that we are connecting the right wires to the right pins, and then use this auto arrange wires option to make it align properly. Let us see what is inside this code. So in this code, what is expected is on the first line, simulations word will come, and on the second line, on cloud word will come. So in principle, simulation on cloud words should be printed on the LCD screen. So we will start the simulation. So you can see simulation on cloud has been printed on the screen. So what if I want another text written onto this LCD? So what I can do is on the first line, I can write Arduino. On the second line, I can write day 2026, and then I will run it again. So this new code has been uploaded onto the Arduino, and you can see a new message Arduino day 2026 appears onto the screen. So this way you can change the text as well, which you want to be appeared on the screen. And likewise, we have multiple experiments, as I mentioned. I will also give you an example of servo motor, which is controlled by a potentiometer. So consider this as your regulator that you use in your house to control the speed of the fan. So this is at the minimum, and we will rotate it, and this changes in the potentiometer will also reflect in the orientation of this servo motor. So we will just start the simulation, and you can see this is at the 0 degree, this is at the minimum, the potentiometer, and as soon as I'm increasing the value of the potentiometer, the servo motor is also changing its orientation. So if I go to the maximum value of the potentiometer, the servo motor is turned to 180 degree right away. So you can control this using the potentiometer as well. We have given the code on the left side. So it just takes the analog value from the potentiometer, and accordingly the code has written that whenever the analog value is low for the potentiometer, the angle of the servo motor should be 0, and as you increase the potentiometer value, the angle should increase from 0 to 180 degrees. So yeah, so likewise we have multiple experiments, and we want all of you to use this website, the Arduino Cloud website, for the documentation part. so that so it gives you all the information regarding the aim of the experiment, components, the circuit diagram, code explanation is also there, line by line code explanation, and an output video is also been shared with you. So you will have an idea of what kind of result you should be expecting from your experiment. So any school, any students or any teachers for that matter have any questions regarding it? You can raise your question. You can raise your hand or write it in chat box as well. Where can we learn the code? Okay, to learn the code, I will suggest you to first use the Electroblox platform. Make sure your logic is right. You can see on the Electroblox website as well. I'll just share my screen. Once your logic is right, the code automatically, or the code has been given to you automatically, and a comment as well. So it is not just you want to just copy paste the code. We are also giving the comments as well as to saying what this line of code is doing. And you can always refer to the Arduino official website. There they have the entire documentation for it. If I can share the link with you. So yeah, I'm sharing the link with you in the chat box. So that is where you will find all the documents, the libraries, the commands which are used in the code. So you can have a look at it. Any other doubt from school, teachers, students? Okay, if not, then we will move ahead with the session. If you have any doubts, we can answer it. If not, we will just move ahead with the session. I will hand over the mic to Rajesh sir again, and he will conclude the session now.
Hello all. Hope you have gone through the sessions and you have learned a lot from today's session for the Arduino Day. So we encourage students first go through the electro blocks, because block-wise programming and all this thing they must have learned with a scratch or anything. So it makes them easy first to learn. So whenever you are trying to learn with electro blocks, I'll just share my screen again. Okay. So I'll just go with the electro block. I'll just create a new circuit again. So this is a very basic thing what you generally see. So what is the basic thing whenever you're trying to load even Arduino on cloud also you can see. So there are two things which are there: initial program settings and configuration, void setup and void loop. These are the two things which are there. So I'll just try to add an LED. So I'm just trying to repeat the things again, but I'm just trying to see the moment I click on LED and I'll take one LED out. Okay, the moment I put that LED inside, you can see that LED is coming on to the screen automatically. But what is happening to the code? So you can see I have added an LED. You can see what is the code output is coming. Now, this is the code output, the LED is in my added at pin number 2. Okay. The moment I try to change the code, I try to change it to pin number 4. So you can see the pin number 4 is been reflected out here. Now, here in the loop, it will say digital write high. So it is say turn on. So that's why it is pin number 4 is turn on means high. And if I say turn off, it will say it is low. Okay. So this is how I always prefer the school children to learn step by step. So if I add something more blocks and all this thing, what are the changes it is trying to do here? Then you can see the time is there. Now wait for 2 seconds. So if I just try to add the wait for 2 seconds, you can say there is a delay of 2 milliseconds. So if I just put 1 second, so it will have 1 millisecond delay has been added. Okay. So this is how we have to go step by step and learn the coding. Once you have gone with the code, learn the code and all this thing, then definitely you can go and learn with the electro blocks. Sorry, not electro, Arduino on cloud. So always whenever you are very much new to coding platforms or we don't know the Arduino part, first go with the electro blocks, then you can always go with the next part which is called as Arduino on cloud. I always prefer to do your first thing in simulation mode only, because there's nothing that you're going to harm this Arduino board or you're going to damage anything, because anything you're trying to do it, you're going to learn in the simulation platform only. Like as you have seen the demonstration for Arduino on cloud, you're not added the register and you're turning on the code and trying to run it. It shows you the LED has blown away. Why? Because the resistance was not there, so high current has flown through it. Okay. So this is what step by step you have to learn the things. So is there any questions or anything that I'd like to see?
Hi, Rajesh. Can I ask a
Yes.
question? Yeah. So we have an Atal Tinkering Lab, and students have been using these Arduino boards, and we as part of this FOSSEE, do you support any other open source hardware apart from the Arduino boards?
See, Arduino board right now we have just Arduino with it, but we are in a phase of development for ESP32. Okay, so where a lot of experiments for the IoT related activities will be also added in it.
Right. Okay.
So right now, because for electro blocks, why we have gone with it, electro blocks, as you can see in that it generates the C code, it generates the Python code also.
Okay.
Okay. So many of the CBSE students, Kendriya Vidyalaya students, they have Python in their curriculum for the 11th and 12th standard, and many of the school teaches Python from the 8th standard also. So we have tried to introduce Python also in it. So it becomes very easy for them to understand Python from both on the both the side.
Got it. Understood.
Yeah, definitely we are in a phase because this platform has recently developed, and we are in the phase of adding ESP32 and many other boards also to it. So even Raspberry Pi Pico will be also added to it.
Okay. Apart from the platform, this platform, do you also support any other open source hardware? I mean, you mentioned Raspberry Pi. Like there is one thing called there is a robotic arm called SO101 from Hugging Face. I think it's also an open source one. Do you people support that as well?
Okay. So for that particular activities and all these things, so robotic arms, or we have got various use of robots and all these things. If you are just concentrating only on robots, okay, so then we have a separate project called as eYantra, where it is dealing with only with robotics.
eYantra. Okay.
eYantra. Okay.
Okay.
But our main focus is for the very newcomer, because eYantra is not going to teach you the basics of Arduino, basics of ESPs or anything. Right now, the children require the basic, because I've seen a lot of children who are there in IIT also, students from the various branches, for mechanical engineering or some other engineering branches, they don't know the coding part. So they have to go through this process of elementary learnings for Arduino and all the things. So as they know for the hello world for this thing, so they have to go with the blink of LED from the start itself.
Yeah.
How to connect various sensors? What do you mean? Because there is a very much confusion between what do you mean by digital sensors and what do you mean by analog sensors?
Yeah.
What has to be written for the analog part?
Yeah. Yeah, I do see, because in our Atal Tinkering Labs, I do see students, connecting this entire circuit and then asking LLMs like the ChatGPT to generate the code and using that code in this.
Yeah. So, but so what here we prefer is always do in the simulation mode. The more you try to do in the simulation, because there's no hardware required, there's no issue with the hardware getting is burned out or anything like that also. So whatever experiments, wherever you feel like you can do this thing, it's a platform available online. You can do this part.
Yeah, we have been using Tinkercad till now.
Yes, Tinkercad is there. The reason why we don't have this Tinkercad with us because Tinkercad requires a login. Very first thing.
Yeah.
For every student or anybody, they require a login, because many places we see student they don't have login also. So if there is some platform which is open, directly they can try to use it. So of course, Tinkercad is bit advanced, but we are almost reaching to that level also again.
Okay. But that's not open source. I think it's from another.
Tinkercad is not open source.
Yeah, right.
So that's why it is free to use. Free to use means you have to log in to it, and then you can use this stuff. So we have that philosophy that we should give everything in open, no login required. If a student wants to do some experiment directly also, they can do it. So there are a lot of learning materials available on our site also, as you have seen for the Arduino on cloud. So students can go through the AIM, the very basic. So we are talking first step for learning Arduino is your physical computing. First step is a physical computing, where you try to learn how to connect switch, how to connect LED, how to connect a sensor. What is the output here that you get it? Now, if I just talked about, I already talked about, there are so many sensors available in your mobile devices also. What you can use mobile devices for doing various physical experiment also. Okay, to write a small program for physics. Okay, if I'm having the pendulum, so gyro sensor is there in that particular thing. The moment you tilt the phone, you can see that orientation of your video changes. So that sensor is available. So if with the application, if I just try to use the pendulum experiment, the phone is attached to the string and you just string it, and you can have that graph of pendulum damping also. That also can be generated with a simple program. Okay, but that's an Android programming that comes in. But main question for this particular session is promoting Arduino and physical computing, that is very much required for the school. Many of the school, they don't have the tinkering labs or utter tinkering labs in the school. But as per the NEP 2020, all the schools, all this skills development is required. Okay, so we are not saying that you have to learn Arduino, you have to learn this thing, but with that Arduino, there's some physical activities that you are trying to do, and you are learning coding also, and doing something in a fun way also. I'll tell you a lot of experiments like students have done it. I've seen like a blooming of a flower. Okay, so flower is just blooming. How you can show it. So there's some part of mechanical comes in, how the gears are rotated, how the flower gets bloom. Then after the sunset, it again closes. Okay. Now this is a very basic concept we are talking of. Now sunset, how I'm going to talk now. LDR comes in. So LDR detects the light. Okay. Now light is detected. Automatically the motor will turn on at the back and it will bloom the flower. Now light is not there, again it will close. Okay, so there are certain things that we have to challenge students with a problem. We are not going to give the solution to them how we are going to do it. Let them think. Let them think. Yeah, you have learned the physical computing. What are the things can be done? Now I've given you a problem. Okay, what are the components? Now let them think. Yeah, I can use LDR now here. Now I can use motor to do this part. Okay. So this is how we generally try to promote it. But first step is always physical computing. Okay. Yeah. Thanks. Any questions here? Yes, you will be getting the certificates for this thing, but it will be somewhere in start of April. The certificates will be generated and it will be issued to you all. So we'll be issuing, your teacher has registered, we'll send an email to the teachers, the certificate has been generated. And from there, I think you can take the things. I request all the teachers to fill the feedback form and upload the photographs and attendance of the children who attended the session. Okay, because those students who have attended the session, that certificates will be generated. Yeah. Any questions here? The feedback form is already shared in the chat also. The teacher can use the chat link to fill the feedback form. And also the photographs. So that is we require for our purpose. Any questions here? The schools who wants to start Arduino lab in their schools or anything, so FOSSEE can definitely help the schools, because we have developed certain curriculums and all these things, so which can help the students to learn the programming from the Electro blocks, then Arduino on cloud and furthermore. Okay. Yeah. So any questions, please unmute yourself and you can ask the questions here. The floor is open. You can please unmute your mic and you can ask the question here. Teachers, if the schools are watching this thing in a group, Please unmute and the students can come forward and ask the questions if they have any queries. Okay. Raja sir, you can come mail us if you want any details for the setups and all those things. We would definitely like to get in touch with you for the further collaborations here.
Definitely. Thank you very much, Rajesh ji. Yeah. Can I have some kind of email or something like that which I can write to?
Yeah, we have this mail ID. I'll just share that thing with you.
Yeah.
I've shared it in the chat window.
Got it. If we have another 2 minutes, would you allow me to share one activity that we are doing with these Arduinos?
Yes.
Yeah. Okay. Thank you. See, we have been using these Arduino boards in adult tinkering labs. Okay. And students are participating in various competitions. Okay. While participating, see, what they couldn't understand is like why they are not able to crack, get rewards, or they move on to the next level in these competitions. So we are coming up with a uh, experience center for our adult tinkering labs, wherein the students who have created certain prototypes using these Arduino boards, they are going to place them in that experience center. Let us call it as a selling point. Why? With that, the student will have an opportunity to actually sell the products, prototypes, what they have made, so that they will be able to clearly understand why the customers are not interested in that particular prototype or so. They will have a first-hand information of why they couldn't really sell it. So for example, we started with small games, with LEDs, like the one which you have shown. They have created an Arduino, using Arduino, they created that LEDs, and it's a kind of game which you have shown it just before a half an hour or so, and creating that selling point, so that students are able to will be able to sell them, understand why the customers are rejecting them, and then improve their products or prototypes.
Okay. So you have created a experience center for all these things here.
Yes. Yes.
It's great. No, this kind of things, truly speaking, the games, whatever we have demonstrated out here, the memory game, you call it, or the line game. So that is required to see the concentration of a child.
Yes.
How much is concentrated while doing this work?
Yeah.
Because initially we find it, yeah, it is very easy for remembering that memory game. But as the level increases, so that concentration also. So gaming is a part where a lot of concentration is required.
Right. Yeah.
Distraction, the moment you get distracted, the game is over.
Right.
Yep. So yeah, it's a good. In fact, most probably from another session of the Arduino Day, we are also calling schools to submit some of their projects, because we are not looking at the projects as I've discussed earlier. There should be always a problem statement, And based on that problem statement, why has been solved. We are not looking at a simple projects like the line following robot or cell balancing robots or anything, because that all things are only for the learning purpose, how you are going to learn the things working. But what exactly you are trying to use this kind of technology and this all learnings to make new things, and what problems you are solving. As I've told in my very first session, that we have the students or anybody should not directly jump in creating the circuit and writing the code. First, what problems you are trying to solve it, first you have to ideate that problem. Okay, initial ideation stage should be there. Then you should go further for the design. You have to talk to the people why we are trying to build this thing. Okay, now take a simple example. For creating a simple buzzing system for the hospital. So people press the key, that bed number comes, that key press is there, and all this stuff. But what if you have continuous heart rate monitoring and all this thing is coming on a small dashboard where 10 bed patients are there? Okay, so continuously monitor it, one single dashboard can be done. Of course, as you said, you're allowing your children to use chat GPTs to program all these things. So we can't stop students to use these technologies. Of course, all these technologies are available, but you have to use it wisely and for productive work. Not only just, it's not a guide that you're going to cut and paste and copy it and it starts working. You have to use this tool as a productive tool, so that your time is more utilized in refining the work rather than coding the things or trying to solving the errors which the code has been generated. Okay, so no doubt in it, people can definitely use it for the coding purpose, but use it in a productive manner. Okay. Yeah, any further questions, please fill the feedback form. That is very, very important to us. And I hope the session was good and informative to you all. And looking forward for your schools to participate in our future activities. And we are really looking forward for your school to get in touch with us. And we will also get in touch with many of the schools so that we can form a collaboration and we can have this lab set up in your schools also. Okay. If there are no further questions, we can stop the session. Okay. Thanks a lot for being with us. Thank you. Have a great day. Thank you.
Thank you very much.
Thank you.